Hi, I'm Matt Burns at the University of Florida. I've been talking quite a bit lately about productive failure and how it fits or where it doesn't fit and does not fit, does and does not fit into reading instruction. And several people have emailed me for additional information, so I decided I would make a quick little video that I could easily share. So let's talk about productive failure and productive struggle within reading instruction. Now, I'm going to freely admit to you that I'm going to show you a meta-analysis today that was done from math, but I think the same principles apply. When you think about learning, and I've talked about this quite a bit, as have others, when people learn, they go through four very specific phases. We start off in the acquisition phase. We're slow and inaccurate. No idea what to do. Where do you even begin? So when people are in the acquisition phase, the best thing we can do is do immediate modeling with explicit instruction. Our task there is to get them accurate. We want people to first be accurate. Once we get them accurate, then we can work on speed, proficiency. Once they're accurate, but they're still really, really slow. That's the people that, they read, the kids that read sound at a time, that do math on their fingers. They can do it, but they really, really, really have to think about it. In that phase, practice, practice, practice. Get them accurate first, then do lots and lots of practice. Once you're able to do it with sufficient speed and accuracy, then they can generalize it to some other setting. Teachers ask me all the time, does speed really matter? And I say, no, it really doesn't. What matters is automaticity. You can't generalize something unless you can do it with automaticity. How do we know if it's automatic? Speed. That's why speed matters. It does matter. But what really matters is automaticity, but we have to get you first accurate, then sufficient speed, then you can generalize the skill. And then once you can generalize it, you can use the information to solve problems. This is the basic learning theory, the basic steps in human learning for kids, through adults, through children learning their basic letter sounds to 16-year-olds learning how to drive a car. We generally speaking go through these phases, and we want lots and lots and lots and lots of practice, but only after we reach some level of accuracy. Now, how does that fit in the conversation about productive struggle? Well, this is a really nice meta-analysis. I'm not sure how to say the names, Sinha and Kapoor, published in 2021, a very nice meta-analysis and review of educational research, which is a top journal. And I got this meta-analysis and I thought, oh, well, perfect. This is problem solving followed by instruction. So that means give them the task, let them try and solve it first, experience their productive failure. And that's called problem solving followed by instruction, as opposed to instruction then problem solving. All right, so what they found was 53 studies, 166 effects. They found a moderate effect size favoring this problem solving then instruction, favoring productive struggle of a 0.36. Well, I saw that and think, well, that's interesting. And I looked even further. They said if you use good effective productive struggle, the effect size even goes up stronger. Wow, that is as high as 0.87. Okay, now you've got my interest. So I got the manuscript and read it, and here's what I learned. Okay, I'll tell you right now, this is for math. I'm talking about reading primarily. It's true for reading and math, I would argue, but certainly for math. So let's look at efficacy of productive struggle. Okay, so the first thing I went and looked to see is let's look at the people involved in this particular study. And this is the breakdown by number of participants. So most of them were 6th to 10th graders, a plurality, not a majority, but 45% 6th to 10th graders. 15% were 2nd through 5th graders. A third of them were undergrads, and 5 of them were others, postgraduate professionals. Okay, now I work with undergrads. I want research on how to help undergrads, of course, but when we're talking about teaching reading and math, I'm really more focused in these grades here, these 2nd through 5th grade and 6th through 10th grade. And, only 15% were elementary school. Then I like to see the stuff that they taught. And the stuff they taught, we look and see, like there was math equivalency, basic sciences, physics, chemistry, biology, medicine, all these other things, which some I'm not sure what they even mean. So very few of these or what I would consider to be just typical math skills we teach in elementary or middle school. Now I look at it by grade. Okay, if we look at it by grade, a couple things jump out at me. Number one, okay, the others group had a mean effect size of 1.03, solid positive effect. And you would notice the range is in the positive. There's the standard error of this, the confidence interval does not include zero. This is a nice effect, a large effect, reliably greater than zero. The confidence interval includes negative for all the other three groups, which means it's not reliably different from zero. But most importantly, look at the effect for second to fifth graders. Negative 0.09. Negative 0.09 does more harm than good. The instruction then problem solving did better than the problem solving then instruction. Productive failure was not effective. Now, the effect was small, I'll admit that, but it was not effective. It is inaccurate to look at these data and say a productive struggle approach was effective for students in second through fifth grade. It wasn't even reliably effective for sixth through 10th graders. It was better, but not reliably so. So I'm not really convinced that it works. Now let's come back to your basic learning theory. I was one time recently observing a kindergarten classroom, and the kindergarten teacher was teaching the letter T. Kids had never seen the letter T before. And she's a good teacher using a good instructional program. And she stands in front of her students and says, gets them on the carpet, they're all sitting there, and says, okay, kids, today we're going to learn something new. We're going to learn what this is, and puts a T on the smartboard. Says, okay, who knows what this is? Now the kids are all sitting on the carpet, and they sit there and stare at her blankly. And then they're kindergartners, so they start getting kindergartner-is, kindergartner-y, or whatever. And they start like raising their hands randomly and getting all squirmy. And okay, so then, okay, stop. Okay, this is a letter. Who knows what letter it is? Same thing. They sit there for a few seconds, staring at her. Hands start going up. She calls on one. The kid says, my dog has nothing to do with the topic whatsoever. They start getting all squirmy. Okay. This is the letter T. Who knows what sound the letter, who knows? She said, who knows what the letter T says? They're in kindergarten. They didn't know what was a letter. They didn't know it was letter T. Are they going to know what it says? No. That went off another 15 seconds. They start getting squirmy, raising their hand. Now, I think she was trying to operate on this idea of productive struggle. Let the kids try and figure it out. But let's go back to learning theory. Productive struggle, I would argue, works more so, if at all, down here. When someone is first learning something, modeling explicit instruction, then lots and lots and lots of practice, then opportunities to generalize it, followed by using it to solve problems. Once the kids demonstrate good initial learning and they can generalize it, then you want to have them engaged in productive struggle. I think that's probably okay. I haven't studied it, but I think that's probably okay. I would argue productive struggle has no place in initial learning, no place in if a person is slow and inaccurate first learning it, it's modeling. If they're then can do it accurately, it's lots and lots of practice and then opportunities to generalize it. All of that way before we ever consider something along the lines of productive struggle. I would have done this. I would have said, okay, kids, today we're going to learn a new lesson, a new letter. It's a letter. Put the letter T up. This is the letter T. Everyone say it with me. T. They'd say T. Good. T. T makes the T sound. T makes the T sound. Okay, say it with me. T makes the what sound? T makes the T sound. The kids will all say, good. T makes the T makes the T sound. Like as in top or T. Oh, that's a bad example. No, really confusing to the kids. I meant TEA. They don't know that. Anyway, I would say two words that start with a T sound. And then I would say to the kids, okay, now turn to your partner, someone you're sitting by, and think of a word that starts with T. Let them do it for a minute. I'm listening as they do it. A couple of them do it correctly. And so in 10 seconds later, I say, okay, I heard such and such say this. That was great. And then I might have them go back to their desks and we'll practice drawing the T and doing all those other things. All of that would happen way before any kind of productive failure. And keep in mind, it took me 10 seconds, maybe 20 seconds to do all that. And there would have been much better initial learning. When you're doing initial learning, the best way is to model it, provide lots of practice. Productive struggle is way down the road once they learn how to generalize it. Hope this is helpful. Get the article. It's a good article. It's a good study, good meta-analysis. Get it, read it over, email me, I'll happily send it to you. Thank you.